Okay, Mia, here is what I came up with for problem number 40. Okay, so on problem 40, they say to you that you have vector A, which is described as negative 3i hat plus 6j hat, and then vector B, which is 7i hat plus 2j hat. Now, it's important for us in this solution to realize what I hat and j hat really mean. We're more familiar with writing Cartesian coordinates, x and y, so the A vector can actually be described as negative 3, 6, because the I hat is the x component and the j hat is the y component. And if we follow that same logic, then vector B is going to be 7, 2. All right, so they're saying that you plot your points and you got your positive x-axis here like normal. And what I was trying to show you with this right here is they're saying that the counterclockwise is considered to be positive theta, which is the usual convention. So with that in mind, the angle that a vector makes can be found by taking the inverse tangent of the y component over the x component. So in this case, for A, it would be 6 over negative 3, which gives you a negative 63 degrees. But what in the heck does negative 63 degrees mean? Well, that's why I went up here to the graph and plotted it, because this green vector right here to the left is what you would see for vector A, because it has a negative 3 for the x direction and a positive 6. So that's why it would fall right here, which means that it is in quadrant 2. So that negative 63 actually needs to be added on to 180 degrees, because that means you fall short by 63 degrees from the 180 degree angle. So if I do that, that gives me 116.6, which means this angle right here, which is your angle with respect to the positive x-axis, is 116.6. And you only have to do that if you are in the second quadrant to try to figure that out. Thankfully, component B is 7, 2. So vector B falls in the first quadrant and would look something like that on your diagram. So I do the same thing and I take the inverse tangent of the y component over the x, so 2 over 7. That gives me an angle of 15.9, which seems to make sense with my diagram. All right, and then for the last part, it asks you if you add A and B together. So it says vector C is vector A plus vector B. Well, since we're dealing with vectors, we have to keep the x and the y components separate. So what I did here is you find the resultant x. So you take ax plus bx. So negative 3 is the ax. 7 is the bx. Add those together, that gives you a resultant of 4 in the x component. We have to do the same thing for the y component. So we take ay, which is 6, plus by, which is 2, gives you 8. So that means my vector C can be described as having an x component of 4 and a y component of 8. I do the exact same thing to find the angle for C by taking the inverse tangent of the y component of C over the x component of C, which is what I have here. That gives me an angle of 63.4 degrees. Now, if you want to check that, you can plot. Okay, so the point 4,8 would look like this. It would be in quadrant 1. And so that would make sense that you'd have an angle of about 63.4 degrees with respect to the